For the 59th problem on this first ACT practice test, as part of a probability experiment, Elliot is to answer 4 multiple choice questions. For each question, there are 3 possible answers, only one of which is correct. If Elliot randomly and independently answers each question, what is the probability that he will answer the 4 questions correctly? So this type of problem is dealing with a concept known as compound probability. And before we look at this particular problem, let's look at a simpler example just dealing with coin flips, or essentially just dealing with heads or tails. And we know that the probability, let's say, of getting heads is just the number of choices we want in our fraction divided by the total number of choices. So there's only one way to get heads, and the total number of choices would be 2, since you can either get heads or tails. But let's say I want to know what's the probability of getting tails twice in a row. So for this type of situation, now we're dealing with compound probability. And it's also important to note that we're dealing with independent probability. So what I mean by that is that let's say I get tails on the first flip, then my second flip, if these two are truly independent, is completely unaffected by the first flip, which makes sense because if you flip a coin 5 times in a row, and let's say you get 5 heads, which would be statistically unlikely, but possible. So let's say you get 5 heads in a row, you might be tempted to think that you're more likely to get heads on the 6th toss. But the reality is that for that 6th toss, it's still 50-50 whether or not you're going to get tails or heads. So those previous 5 coin tosses make no difference for that 6th toss. So for this problem, these coin tosses, we're dealing with independent probability, but in this particular problem that we're trying to solve, the answers are independent. They do give us that information. So back to this problem, the probability of finding heads twice in a row is just going to be the probability of, on our first flip, of finding heads, multiplied by the probability on our second flip of finding heads. So when dealing with compound probability, it turns essentially the problem into a multiplication problem. And since we know that the probability of getting heads or tails would be 1/2, so this probability is just 1/2, and then we multiply by the probability of finding tails again, which is still 1/2 because the coin flips don't affect each other. And now just multiplying straight across in the numerator and denominator, you're left with 1/4. So the chance of getting 2 tails in a row is 1/4. And one of the easiest ways to see that this is true, that we would indeed multiply, is by looking at essentially a tree graph. So let's say on your first flip, you can either get heads or you can get tails. And then on your second flip, let's say you got heads the first time, then you have 2 choices. You can either get heads again or tails. But let's say you got tails the first flip, then from that flip, there are 2 choices. You can either get heads or you can get tails. So you can see that there are in total only 4 choices. You can get heads heads, heads tails, tails heads, or tails tails. So this choice of getting tails and tails again would be this. There's only 1 chance of doing that out of our 4 choices. So with all of this in mind, let's go back to our particular problem. We know that for each question, there are only 3 possible answers, and one of those is right. But we want to know what's the probability that Elliot will answer the 4 questions correctly. So we have 4 questions, so I can put a mark for each of these 4 questions. And for each question, there are 3 choices, one of which is right. So let's say the probability of getting a correct answer, I'll just mark as C, is, let's see, we have 1 possible way of doing that, and the denominator, being the total number of possibilities, would have to be 3. So the probability on one question of getting the correct answer is 1/3. But we want to know what's the probability of getting correct answers for all 4 of our questions. So to do this, like our previous compound probability problem, we just want to find the probability of getting a correct answer for each of these different slots, and then we'll multiply all those probabilities together. So for the first choice, the first question, the probability of getting it correct is 1/3. And that would be true for the second, the third, and the fourth questions. And then now, since this is a compound probability problem, all we have to do is just multiply all of these together, meaning we just have to multiply straight across in the numerators. And since they're all 1, the product would have a 1 in the numerator. And in the denominator, we're multiplying 3 by itself 4 times, which is 3 to the 4th. And that evaluates to 81. So the probability of getting all 4 of these questions right is 1 out of 81 if Elliot was to just randomly guess. And you can see that choice letter E would be the correct answer.